Hydrocarbons are molecules that contain carbon and hydrogen, and they're an important category of molecules because we use them for fuels and for building materials for synthetic materials. There's many different hydrocarbon molecules because carbon has the ability to bond to itself and make long and complicated chains. So there's millions of different organic and hydrocarbon molecules. So in this slide, we're going to look at how to name hydrocarbons. We start by identifying the longest continuous chain. And now this doesn't always mean the chain that's written straight across. But looking at this molecule right here is our longest continuous chain. So the root name of this molecule is based on how many carbons are in this longest chain. So we look at this, we have 1, 2, 3, 4 carbons in the chain. So our root is going to be bute. And the ending is ane if you have single bonds, ine if you have double bonds, ene if you have double bonds, and ine if you have triple bonds. So in this case, we have single bonds, so it's butane is our root name. The next step is to name the branches. So you can see that this piece right here is a branch. And we name it based on how many carbons. So the branch has 1 carbon, so its name is going to be meth. And we'll end it in YL because it's a branch. Branches get the YL ending. Then we're going to identify where that branch is by numbering the carbons in the longest chain. Now I've already numbered them, and you number them from the end that's closest to the branches. So in this case, I have it numbered closest to the branch. And so we're going to call this 2-methylbutane because the branch is on carbon number 2. You can see that branch is attached to that carbon. So that's the name of that molecule. Let's look at the next one. So our longest chain is right here. Now this time I'm going to number from this end 1, 2, 3, 4, 5 to be closest to the branches. So 5 gives us pent. And then ane, because we have single bonds, so that's pentane. And this one has 3 branches. We have this branch, this one, and this one. So all 3 of the branches have 1 carbon, so it's still methyl. But we're going to call it trimethyl because there's 3 of them. So we have 3 1-carbon branches. And then we identify where they are. 2 of them are on carbon number 2, and 1 of them is on carbon number 4. So we're going to call it 2,2,4 trimethylpentane. And that's the name. Now on this last one, we don't want to go straight across for our longest chain because if we, instead of going straight across, we go down, you can see that that's a longer chain. So that chain contains 4 carbons, whereas if we went straight across, it would only contain 3. So this is our longest chain, 1, 2, 3, 4 carbons. And so we're going to call it bute. And ane. So this is also a butane like our first one. The branch, so now this piece is a branch. And it's bonded to carbon number 2, so we're going to call it 2-methylbutane. Notice these 2 molecules from the previous slide ended up with the same name. They are both 2-methylbutane, and that's because they are actually the same molecule, just drawn in different ways. If you remember, this second molecule had an odd shape to the main chain. So if we think about the longest chain right here, and let's think about straightening that out. So we'll bring this piece and write it up there and move the branch up as well. So I'm going to start with this CH3 connected to this CH2. So that's these pieces, and they're connected to a carbon that has a hydrogen that also has a branch of CH3, and then it's connected to this CH3. So that's just rearranging this particular molecule, and now you can maybe see that's the same as the first molecule. It's a mirror image and upside down, but it's the same atoms arranged in the same positions. Let's do some more. If we have the name, let's be able to draw the structure. So again, let's start with the root. The first piece, hex, that means that we have 6 carbons. So I'm going to draw my 6 carbons. And then ane means they're all single bonds, and I have drawn those single bonds. So that's what the ane means. And then our 3-ethyl, that's talking about the branch. So eth means 2 carbons, and 3 is telling us what carbon it's on. So I can number from either end. I'll number my carbons, 1, 2, 3. So right here on carbon number 3, I'll draw a branch of 2 carbons. And so that's what the name tells us. What the name doesn't tell us is how many hydrogens. And so here you have to remember that each carbon is going to get 4 bonds. So this first carbon has 1 bond, and so I'm going to add 3 hydrogens, and that gives me 4 bonds. My second carbon has 2 bonds, so it needs 2 hydrogens. The third carbon has 3 bonds, so it needs just 1 hydrogen. This carbon needs 2. This carbon needs 2. And our last carbon needs 3. Now this is not the condensed structural formula because we're writing all the hydrogens separately. For the condensed structural formula, we group the hydrogens. So here's what I'm going to do. I'm going to erase these hydrogens, and instead I'm going to write it as H3. Okay, same thing here. Erase these hydrogens and write it H2. So these also become H2. This becomes just H. And I forgot to do these, but this one's going to be CH2, CH3. We need the hydrogens there. Then on carbon 2, we'll simplify that to H2. And this one will simplify to H3. So notice the end carbons have 3 hydrogens. The middle carbons have 2 unless there's a branch, and then each branch reduces the number of hydrogens. Now the other thing I want to show you is the line drawing. And so for the line drawing, it's like a zigzag line where the end of the line represents a carbon. So here we have 6 carbons, so I'm going to do 1, 2, 3, 4, 5, 6. So that each end represents a carbon. And then on carbon number 3, 1, 2, 3, I'm going to draw 2 more carbons. So that's the line drawing. And remember, every end or joint represents a carbon. The hydrogens aren't shown because you can easily fill them in by knowing how many hydrogens to make 4 bonds on a carbon. So there's our first one. Let's look at the next one. We have the root name is propane. So prop means 3 carbons. So I'll draw in 3 carbons. And ane means single bonds. So I have the single bonds there. Then we look at this portion right here, the 2,2-dimethyl. The meth part means the branch has 1 carbon. Di means there's 2 of them. So we have 2 branches of 1 carbon. and they're on carbon number 2 and carbon number 2. So I'm going to draw a branch there and a branch there. And so there are my carbons. Now the last step is to fill in with the hydrogens. So my first carbon here has 1 bond, so it needs 3 hydrogens. And that's true of all these carbons that are on the end. Okay, and my middle carbon, it already has 4, so I'm just going to make this bond a little longer to show it doesn't have any hydrogens. Now for the line drawing here, I have 1, 2, 3 carbons with a branch and a branch. And that's the line drawing for that. So 3-ethyl, 3-methyl pentane. Again, start with the root, pent, 3 carbons. No, 5 carbons, sorry, pent. Prop is 3. So there's our 5 carbons. Then we go to the branches. We have a meth branch, which is a 1 carbon, and an eth branch, that's a 2. And both of them are on carbon number 3. So we go 1, 2, 3. Here's carbon 3. So we're going to put a 1 carbon branch and a 2 carbon branch on carbon number 3. And then we fill in the hydrogens. This one needs 3. This one needs 2. This one already has 4 bonds. This one up here needs 3. We go down, this one needs 2. This one needs 3. This one needs 2. And this one needs 3. And so that's our condensed structural formula. For our line, we'll do 1, 2, 3, 4, 5. And then on carbon number 3, we have 1 carbon branch and a 2 carbon branch. And there's our line structure. Last one, we have 2,2-dimethylbutane, starting with the root, but. That tells us 4 carbons. 1, 2, 3, 4. And then we have methyl, that's 1 carbon, and 2 of them, and they're both on carbon 2. So I'm going to put a branch on this one, branch on that. So 2,2-dimethylbutane. Filling in the hydrogens, this one needs 3. That one already has 4 bonds to carbon, so no hydrogens. But these 2 ends are both going to get 3. This middle carbon gets 2 hydrogens, and then 3. And then for our line drawing, we have 1, 2, 3, 4. Carbon 2, we have 2 branches. Alkenes and alkynes. Alkenes have a double bond, and alkynes have a triple bond. So the difference in naming, and I just brought the rules over here, that we're going to find the longest continuous chain, but it must contain the double or triple bond. And now our ending, instead of being ane, is going to be ene or ine. So let's name these molecules here. We'll start by identifying the longest chain. Here it is. And we could have gone down and picked up that carbon and the other be the branch. It doesn't matter. So how many carbons do we have? 1, 2, 3, 4. We'll go ahead and number them. So 4 is but. So this is butene, E-N-E, butene. And we also need to identify where the double bond is. And so you can see the double bond is between carbon 2 and 3. And so we're going to call that 2 using the lowest number. So this is 2-butene. Then we're also going to identify the branch. We have a branch right here. And so that is a 1 carbon branch. It's on carbon number 2. So we're going to call that 2-methyl 2-butene. Now this hydrogen here isn't a branch. They're just showing the orientation of that hydrogen. But that's just the hydrogen on the carbon, so we're not going to name it. Let's look at the next one. Now this one, our longest chain has to contain the double bond, so we can't take the zigzag piece. We've got to have the double bond. So we'll go this direction because that's the longest part that contains the double bond. Also in the numbering, we're going to number it so the double bond gets the smallest number. So we're going to number it 1, 2, 3, 4, 5. So this is pentene. Pent for 5 carbons, ene for a double bond. And we're going to call it 1-pentene because the double bond is on the first carbon. And then when we look at the branch, we also have a branch. And the branch is on carbon 2. It's a 2-carbon branch, so we're going to call it ethyl. And it's 2-ethyl 1-pentene. Okay, so looking at the next one here, the longest chain, and it's got to contain the double bond, so we're going to go with this. And it's 1, 2, 3, 4, 5 carbons. Now notice we have a bromine on that. We're going to name that as a branch. So 5 is pent, so this is pentene. It's 2-pentene because the double bond is on carbon number 2. And then the branches, we have this branch, which is a methyl, and we have this branch, which is a bromo. So bromine, we'll call it bromo. So we're going to call this 5-bromo 2-methyl. That's a Y. 2-pentene. And that's the name of that one. So let's look at these line structures and come up with a name from the line structure. So again, we want to identify the longest chain that contains the double bond. And remember, there's a carbon at each of these spots. So those are our carbons. So our longest chain is going to be right here. I'm going to number from this end, closest to the double bond. So we have 5. It's pentene. And it's a 2-pentene because the double bond is on carbon 2. And we also have some branches. We have this branch and this branch. So both of the branches are methyl. So we'll call this a 3,4-dimethyl 2-pentene. This one, we have our longest chain being right here. And we'll number them 1, 2, 3, 4, 5, 6, 7. So 7 is heptene. And the double bond is on the very first carbon. The branches, we have this branch and this branch. So again, we have 2 1-carbon branches, so they're methyl. So this one we have 5,6-dimethyl 1-heptene. This molecule, we don't have branches, it's just the longest chain. So we can number it 1, 2, 3, 4, 5, 6, 7, 8. And if we numbered it the other way, 1, 2, 3, 4, 5, so it doesn't matter. We're going to end up with the double bond between 4 and 5. So 8 is oct. and then we have ene for the double bond, octene. And we identify where it is. It's on 4. So 4-octene. And we have no branches, so that's the name. This one, they drew it straight because when you get a triple bond, it makes the molecule straight around the triple bond. It's linear, but we have a carbon, 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 carbon. So the end of each line and between that triple bond is all carbon. So our longest chain is here. Or you could have gone down instead. They're the same. And we number it 1, 2, 3, 4, 5. So 5 carbons is pent, ene, pentene, and the double bond is on carbon number 2. So this is our double bond. Oh, actually, we have a triple bond here. Sorry, it's not ene, it's yne, Y-N-E, because it's a triple bond. All right, and then branches. We do have a branch. Right here, we have 1 carbon, so that's methyl, and it's carbon number 4. So it's a 4-methyl 2-pentyne. So here are the same problems with the answers typed up, so you can see them a little more clearly. Here are some more practice problems. I recommend you pause the video and try these on your own, and then you can turn it back on and see the answers. The first one, the root name is hex. So hex is 6 carbons. Ane means single bonds. 3-methyl, carbon 1, 2, 3. We'll put a CH3 group. And then add the hydrogens. H3, H2, H, H3. Oh, sorry, that's H2, H2, H3. So the line drawing, 1, 2, 3, 4, 5, 6. And on carbon 3, you have a methyl. This one, we still have the root of hex, so we're going to do 6 carbons. This one has a double bond on the first carbon. So the ene means double bond, the 1 means the first carbon. So we'll make a double bond there. Then we have a 4-methyl, so carbon 1, 2, 3, 4 gets a methyl, CH3. And then we add the hydrogens. That first carbon has 2 bonds, so we only want 2 hydrogens. This one needs 1. It's got 2 bonds plus that bond. So it's got a total of 3 in the bond, so 1 hydrogen. This one's H2. This one is H, H2, and H3. Our line drawing, 1, 2, 3, 4, 5, 6. These should be solid lines. Double bond on the first carbon, 1, 2, 3, 4. Branch on carbon 4. 2-heptyne. So YNE is a triple bond. Hept is 7. So we have 1, 2, 3, 4, 5, 6, 7. And carbon 2, 1, 2, we put a triple bond there. Then we fill in the hydrogens. H3. This carbon's got 4. The next carbon has 4. And these middle carbons give 2 hydrogens. And then the end one has 3. 3,4-dimethyl 1-pentyne. So we've got yne, triple bond. Pent is 5 carbons. So 1, 2, 3, 4, 5 carbons. Triple bond on the first. That's our 1-pentyne. And then 3,4-dimethyl, so carbon 1, 2, 3, put a methyl on that one. And also on carbon 4. methyl groups on those. This carbon needs 1 hydrogen. This carbon has enough. This one needs 1. This one needs 1. And this one needs 3. So the line drawing 1, 2, 3, 4, 5. We got a triple bond on the first carbon. And then on carbon 3, we have a methyl, and carbon 4, we have a methyl. And I missed the line structure for their 2 heptine. 1, 2, 3, 4, 5, 6, 7. And triple bond on 2. And on the lines, if you want to make it linear around the triple bond, that's appropriate as well.